Hello everyone and welcome back to ProgrammerzET. In our previous lesson, we've defined finite automata and we've seen an overview of deterministic finite automata and non-deterministic finite automata. In today's video, we'll see how we can construct deterministic finite automata, and we will see an example. In our previous video, we've defined deterministic finite automata as a finite automata where for every state and input there is exactly one possible next state or transition. And we have also defined finite automata by 5 tuples: the possible states, inputs, transitions, initial state, and final state. In today's video, we will see an example on how to construct deterministic finite automata, and we will do it step by step. So let's see the example. Okay, construct a DFA that accepts all strings over 0 and 1 ending in 0, 0, 1. The first step is to identify the 5 tuples in this example. So step 1, first we will determine the states. The first state is the initial state, which is required, and to determine the how many other states we have for this to construct this DFA, we will see the example. This size ending in 001, so 3 digits. So we will have next three states. We will name them Q1, Q2, and Q3. This is ending in 0, ending in 00, and this one is ending in 001. And the next is the inputs. Inputs are 0 and 1. And transition. Identifying the transition table is the next step. So the initial state is Q0, and the final state, which is Q3, the final. The next step, step 2, is constructing the transition table. To construct the transition table, on the x-axis we will write the input symbols 0 and 1, and the y-axis we will write the states. Q0, which is the initial state, Q1, Q2, okay. The first Q0 we say it in it's null. The Q1 ending in 0, Q2 ending in 00, and Q3 ending in 001. So to determine where Q0 goes when getting the input 0 and getting the input 1, we will concatenate it with epsilon, and we will figure it out. So epsilon 0 and epsilon 1. So we'll check epsilon 0 in the y-axis. If it's present in the y-axis, we will check is there epsilon 0 here? No. So we will cancel out the epsilon and we will check for 0. Is 0 present here? Yes, right here, which is Q1. So we'll say Q0 when getting the input 0, it will go to Q1. And we'll check for epsilon 1. Is epsilon 1 present here? No. So we'll cancel epsilon. And we will check for 1. Is 1 present here? No. So we will cancel 1. What's left? Nothing, which is null. So null is epsilon, which is Q0. So we write Q0 here. And for the next, for Q1, we will check 0, 0 and 0, 1. When getting 0, the input 0, and when Q1 getting the input 1, 0, 1. So we will check for 0, 0 in here. Is 0, 0 present here? Yes, here. So Q2. And we will check for 0, 1. Is 0, 1 present here? No. So we will cancel 0. Is 1 present here? No. So we will cancel it. what's left? Null. So epsilon, which is q naught, and we'll check for q2, which is 0 0 and 0 0 0 0, and q2 with 1 0 0 1. We'll check for 0 0 0 here. If is it present here? No. So we will cancel 0, and we'll check for 0 0 present here. So q2, and we will check for 0 0 1. Is 0 0 1 present here? Yes, here. So q3, and we'll check for q3 finally. 0 0 0 0 0 1 0 1 0, and 0 0 1 1 1 1. Okay, is 0 0 1 0 present here? No, we will cancel 0. Is 0 1 0 present here? No, so we'll cancel 0 again. Is 1 0 present here? No, so we'll cancel 1. Is 0 present? Yes. Where? q1. And when getting the input 1, we'll check if 0 0 1 1 present here. No, we'll cancel 0. And is 0 1 1 present here? No. Is 1 1 present? No. Is 1 present? No, which is null, so q naught. So our next step, once we have the transition function, is to construct the DFA diagram. So first we will write the states. Q naught, the initial state, so it will be indicated with an arrow. Then q1, q2, and the final state, which is q3, which will be indicated with double circles. So q naught getting the input 0 goes to q1, and when getting the input 1, it goes to itself. q1 when getting the input 0 goes to q2, and when getting the input 1 goes to returns to q naught. When q1 gets the input 0, it goes to q2. So here. So when q2 gets the input 0, goes to itself, and when getting the input 1 goes to q3. And finally for q3, when getting the input 0, goes to returns to q1 right here, and when getting the input 1 goes to the initial state q naught here. When getting the input 0, and when getting the input 1 goes to the initial state, which is q naught with 1. So the this is step 3. Step 3 is constructing the DFA diagram, and the final step is to check the acceptance of strings. Step 4. So as long as strings end with 001, it has this DFA accepts, else it will reject. So let's check it. For example, let's say 1 1 0 0 1 0 0 0 1 and 1 0 1 0 0 1. So let's check, and okay, let's see another. Let's check 1 0 0 0. Let's check 0 0 1 1 0. Let's check 0 0 1 1 1. So let's check the first string. For a string to be accepted, first it must start from the initial state and ending the final state, right? So let's check 1 here, so and another 1. We'll repeat the step. 0 0, and when getting the input 1, it reaches to the final state. So this will be accepted. And let's check for this 0 here, another 0 here, another 0 here, and 1 goes to Q3. So it started from the initial and in the final, so this will be accepted. And let's check for this one. 1 here and 0 goes to Q1, and with 1 returns to Q0, and with 0 goes to Q1, and with another 0 goes to Q2, and finally with 1 goes to Q3. It started from the initial state and in the final state, so this will be accepted. And let's check for 1 0 0 0. With 1 it goes to itself from the initial state, goes to itself, and with 0 goes to Q1, and with another 0 goes to Q2, and finally with 0 goes to Q2. It started from the initial state but ending Q2, which is not the final state, so this will be rejected. And let's check for 0 0 1 1 0. This must be rejected as well because it doesn't end with 0 0 1. So let's check 0 goes to Q1, with another 0 goes to Q2, with 1 goes to Q3, and with 1 returns to Q0, and with 0 goes to Q1. It started from the initial but ending Q1, which is not the final state, so this will be rejected. And finally 0 0 1 1 1. Okay, from the initial state 0 and 0, 1 goes to Q3, with 1 goes to Q0, and another 1 goes to Q0 itself. It started in the initial state and end in the initial state as well, so this will be rejected. So this is it. These are 4 simple steps, and this is an easy method to construct DFA. So if you find this lesson helpful, please subscribe and like my video and share to others. It will really help me grow, and it will motivate me to do more lessons for you guys. And thank you for watching, and in the next lesson we will see how to construct non-deterministic finite automata with examples. If there is any question you want me to explain, please write in the comments, and I will see you in the next lesson. Until then, goodbye.